Hello, the topic we are discussing today is chi-square. The objectives are: the students will be able to calculate the chi-square. They will know where to use chi-square. They will also learn how to use non-parametric test. Chi-square is a non-parametric test of significance that is used to compare frequency counts on categorical variables. Chi-square is not a measure of the degree of relationship, but it is merely used to estimate the likelihood that some factor other than chance accounts for the apparent relationship. In chi-square, our null hypothesis is that our observed frequencies will not be different from the expected frequencies. The word non-parametric means that they do not rely on assumptions about the underlying population parameters as is required by the parametric tests. Non-parametric tests have less power than parametric tests. Non-parametric tests are used when the nature of the population distribution from which the samples are drawn is not known to be normal. The variables are expressed in nominal scale, that is, classified in categories and represented by frequency counts. The variables are expressed in ordinal scale, that is, which can be ranked in order. Chi-square is a non-parametric test of significance that is used to compare frequency counts on categorical variables. Types of chi-square. Chi-square test for goodness of fit. This is used to compare obtained frequencies with expected frequencies on one variable. Chi-square test of independence is used to compare obtained frequencies with expected frequencies on two variables. For example, do students really like pizza? In order to get the answer, first we will make our question more specific, whether students prefer pizza over burger. Now we should randomly select a sample of students and ask each one about his or her preference. Now we count the number of students preferring each category. These data are not measures and therefore means cannot be calculated. The chi-square is not a measure of the degree of relationship, but it is merely used to estimate the likelihood that some factor other than chance accounts for the apparent relationship. The chi-square makes certain assumptions. The first assumption that chi-square makes is the observation must be independent and the variables also must be independent. The variables under study have underlying contiguity, which means continuity in variables. The data should be in nominal or classificatory scale of measurement. The data should either be in terms of frequencies or proportions or percentages. And finally, the number of samples should be less so that the degrees of freedom or DF should be within 30. The chi-square ratio is as follows. Chi-square equals to sigma FO minus FE whole square divided by FE, where FO denotes the observed frequency and FE denotes the expected frequencies respectively. Inspection of the chi-square shows that chi-square is a descriptive measure of the magnitude of the discrepancies between the expected frequency and the observed frequency, which implies that the greater the discrepancy relating to expected frequency, the greater the contribution of chi-square. And if there is no discrepancy, the chi-square will be 0. The squaring process means that chi-square is always a positive quantity, regardless of the direction of the discrepancies. Now let us look at an example of calculating chi-square. The following table shows frequencies where 43 males and 52 females are categorized as tall, medium and short. The null hypothesis is that gender is independent of height. That is, there is no association between gender and height. Let us look at the steps to calculate chi-square. The first step is to calculate the row total and the column total. The row total of males and females who are tall is 44. The total of those who are of medium height is 36, and that of those who are short is 15. Likewise, calculate the column total. The total number of males is 43 and females is 52, and the grand total of all the subjects is 95. And then calculate the corresponding expected frequencies, that is Fe, for each score. To calculate Fe for the score 12, we need to multiply the row total 44 into the column total 43 divided by the grand total 95, which gives us the expected frequency of 19.9. Likewise, we calculate Fe for the score 22. We need to multiply the row total 36 into the column total 43 divided by the grand total 95, which gives us the expected frequency of 16.3. Likewise, to calculate Fe for the score 9, we multiply 15 into 43 divided by 95, which gives us the expected frequency of 6.8. To calculate Fe for the score 32, we need to multiply 44 into 52 divided by 95, which gives us the expected frequency of 24.1. In similar manner, we calculate Fe for the score 14 and we obtain the value 19.7. And also for the score 6, we obtain the Fe value of 8.2. Once we calculate the expected frequencies for all the scores, we need to do the following steps. Further steps to calculate is to subtract Fe from Fo, that is Fo minus Fe. Next, we square the result, which is Fo minus Fe whole square. Divide this result by Fe, that is Fo minus Fe whole square by Fe. Add all the results that you obtain using the formula sigma Fo minus Fe whole square divided by Fe. Now, let us look at the calculations. Chi-square is equal to sigma of Fo minus Fe whole square divided by Fe. For example, we substitute the observed frequency 12 minus the expected frequency 19.9 whole square divided by expected frequency 19.9. In this way, we substitute each individual score using the formula. We then systematically calculate Fo minus Fe whole square divided by Fe for each score and add all of them, which gives the values of 3.14 plus 2.59 plus 1.99 plus 1.65 plus 0.71 plus 0.59, which equals to 10.67. Following which, we will find the degrees of freedom as follows. df is equal to r minus 1 into c minus 1, where r is the number of rows and c is the number of columns. Here, the df is 3 minus 1 into 2 minus 1, which gives us the df value of 2. Now, using the obtained df, we will consult the chi-square table and find the relevant critical value, and then we will make a decision on the significance of the obtained value. Table showing the critical values of chi-square, we will consider the levels of significance of 0.05 level and 0.01 level. The df of 2 at 0.05 level is 5.991 and at 0.01 level it is 9.210. Our obtained value 10.67 is greater than the critical value at 0.01 level, that is p less than 0.01, which is significant. So, we accept our alternate hypothesis and reject the null hypothesis. We would say that there is statistical evidence that gender is dependent on height. That is, there is an association between gender and height, which can be denoted by chi-square open bracket df of 2 comma capital N equals to 95 close the bracket, which equals to the chi-square value 10.67 comma p less than 0.01. Now, let us look at another example which eliminates the need to calculate the expected frequencies. The following data are obtained in response to locus of control scale from a group of males and females. Let us find out if there exists a significant relationship between the locus of control and gender. As we see here, this is a 2 by 2 contingency table with degrees of freedom 1. There is a simple formula that eliminates the need to calculate the expected frequencies for each cell. To calculate chi-square in this method, these are the following steps. The procedure is to indicate scores of males as A and B and those of females as C and D. Next, we calculate the row total and the column total. And finally, we apply the formula to obtain the chi-square value. Now, let us look at the table and calculate the row total and the column total. To calculate the row total, we add the scores of all the males, that is 20 plus 40 equals to 60. To calculate the row total of females, we add 25 plus 15, which equals to 40. And to calculate the column total of internal locus of control of males and females, we add 20 plus 25 to give us 45. To calculate the column total of external locus of control, we add 40 plus 15 equals to 55. And the grand total, which is the sum of all the scores, is obtained by A plus B plus C plus D, which equals to 100. Now, let us apply the formula to obtain the chi-square value. Chi-square is equal to n of A into D minus B into C whole square divided by A plus B into C plus D into A plus C into B plus D. When we substitute the values, it would be 100 into 20 into 15 minus 40 into 25 whole square divided by 60 into 40 into 45 into 55. With further calculations, we obtain the chi-square value, which is 8.25. Next, we calculate the degrees of freedom, which is degrees of freedom equals to r minus 1 into c minus 1, which gives us the value 2 minus 1 into 2 minus 1 equals to 1. Now let us refer back to the critical value table. With df of 1, the table value of chi-square at 0.05 is 3.84 and at 0.01 it is 6.64. Our obtained value 8.25 is greater than the critical value at 0.01 level, that is p less than 0.01, which is significant. So we accept our alternate hypothesis and reject the null hypothesis. We would say that there is statistical evidence that locus of control is dependent on gender. In other words, there is association between locus of control and gender. Now we can denote it by saying chi-square open brackets 1, which is the df, comma capital N equal to 100, close the bracket, equals to the chi-square value 8.25, comma p less than 0.01. Now let us look at chi-square test for goodness of fit. A special use of chi-square occurs when we want to investigate a set of data measured on only one variable. For instance, suppose we are not interested in finding out the gender differences for preference of food. However, we are interested in students' preference for types of food. Now consider the following example. Suppose an experimenter selected 100 students randomly and asked them about their preference of pizza and burger. The null hypothesis is that there is no preference. So we would expect 50 students to choose each type. Then our expected frequency would be 50. Suppose 60 students out of 100 preferred pizzas and 40 preferred burgers. And the steps to calculate chi-square are: the procedure is to calculate expected frequencies on the basis of null hypothesis that all cells should be equal, that is, total number of subjects divided by number of columns, which is 100 divided by 2 gives us the value 50. Using the observed values and the expected frequency, apply the chi-square formula as before. Next, calculate the degrees of freedom, which is C minus 1, that is column minus 1. Now let us calculate the values following the given procedure. Here we see the observed frequency for pizza is 60 and for burger is 40, and the expected frequency is 50 for both the groups. We subtract expected frequency minus the observed frequency, which gives us the value 10 for the pizza group and minus 10 for burger. Next, we square the obtained values, which gives us 100 for each group. And finally, we divide it by the expected frequency, which gives us the value 2 for each group. Applying the formula gives us the chi-square value. Chi-square is equal to sigma of FO minus FE whole square divided by FE, which equals to 2 plus 2, that is 4. Now let's calculate the df, which is C minus 1. Since there are only 2 columns, the df would be 1. With df of 1, the table value of chi-square at 0.05 is 3.84 and at 0.01 it is 6.64. Our obtained value, that is 4, is greater than the critical value at 0.05 level, that is p less than 0.05, which is significant. So we accept our alternate hypothesis and reject the null hypothesis. We would say that there is statistical evidence that students prefer pizza over burger, which can be denoted by chi-square open brackets df of 1 comma capital N, which is 100 close brackets equal to the chi-square value 4 comma p less than 0.05. As we have seen, chi-square is a non-parametric test of significance that is used to compare frequency counts on categorical variables. The chi-square is not a measure of the degree of relationship, but it is merely used to estimate the likelihood that some factor other than chance accounts for the apparent relationship. We have also seen two types of chi-square tests. Chi-square test for goodness of fit is used to compare obtained frequencies with expected frequencies on one variable, and chi-square test of independence is used to compare obtained frequencies with expected frequencies on two variables. And finally, we understand that inspection of the chi-square is a descriptive measure of the magnitude of discrepancies between Fe and Fo.